In this screencast we're going to look at the Wheatstone Bridge, and if we have time we'll move on to the Kelvin Bridge. The Wheatstone Bridge is a ratiometer really, in which you use the ratio of resistors to calculate an unknown resistor value, Rx. When the bridge is balanced, then we know that the ratio of R1 to R2 is equal to Ra to Rx. We're going to see why that is so. Here I have a Wheatstone bridge. If I measure the voltage from C to D, the voltage from C to D is the voltage at V, so the voltage up here, divided by the total resistance, which is R1 plus R2, multiplied by this resistance R2 to give me that voltage. Similarly, the voltage from B to C is the voltage at V divided by the divided by the total resistance R1 plus R2. That gives me the current multiplied by the resistance R1 gives me that voltage. Similarly, for the voltage from A to F is the voltage of V divided by the total resistance, which is the current, then multiplied by the resistance Ra. And finally, the voltage EF or FE is equal to the voltage V divided by the total resistance Ra plus Rx multiplied by Rx. Okay, so here's our equations that we just derived. So if I look at the ratio of the voltage from B to C, their voltage is from C to D, and the voltage from A to F to the voltage from F to E, basically I'll substitute in. So I'm going to substitute this value in here, and this value in there, and this value in there, and that value there. And that will give me something like that. Immediately we can see. So there's the V's gone, and we can see R1 and there's R2 here, so they'll cancel out, and Ra and Rx over here will cancel out. So that's them gone. So we're left at R1 over R2 equals Ra over Rx. R1 over R2 is equal to Ra over Rx. And that is the Wheatstone Bridge. Now there are some problems with the bridge. It may be balanced when these things happen, but there can be some inaccuracies. So for example, there might be some voltage dropped across the wire here, or some voltage dropped across the wire here, there, and there. And when the unknown value Rx is very small, then these voltage drops can have a significant effect on the accuracy of the bridge. To combat that, the Kelvin Bridge has been developed. So it's a slightly modified Wheatstone Bridge. So first and foremost, if we have this resistor connected immediately at Ra, we'll eliminate this voltage loss. And if we have this resistor here connected here, we'll negate this loss. However, there'll still be some losses in here. So what Kelvin did was he put in another two resistors that were a fraction of these values here, and when we do this analysis, the wire here I'm going to consider as a small resistor, RW. And we will look at that in another video.